Hi guys, so today we're going to be proving the Tan-Chord theorem, and I'll be showing you guys how to prove the Tan-Chord theorem in under 3 minutes, right? So let's begin. So firstly, we're going to need to construct a line, right? So we're going to be constructing a line from E to O and to the circumference, right? And from there on, I'm going to join it right here, all right? Yeah, let me do frequency. I'm going to join it right here, right? And this is going to be called M, right? So you're going to write here that construct OM and join it to DM, right? DM, right? Finish and clear. Now from there on, after doing that and telling your examiner that, you're going to then say, if you see what I'm seeing right now, you're not going to say if you see what I'm seeing, but you're going to say E angle M angle EDM is equals to 90 degrees. Now, where is that 90 degrees? Here it is. Alright, angle in a semi-circle, right? Now, the second one, which is the other one, which is MEG. MEG is equals to 90 degrees. Raising the red radii perpendicular to 10, right? There it is, right? MEG, right? Now, since MEG and EDM both are equal to 90 degrees, we're going to write it here. EDM equals to MEG. They're both equal to 90 degrees. Then this means that MEF is equals to MDF, right? Of which angles in the same seg, right? And just like that, angle F EG it equals to angle D, and we have proved Tan-Chord. Now for someone who's confused, don't be confused. Like, this is 90 degrees and this is 90 degrees, right? And MEF, which is this piece, let me use the red, MEF is equals to MDF, right? And both of them are equal to each other. So if they are equal to each other, then this means that FEG is equals to D, meaning that if they're equal to each other, let's say it's 45, then this is 45 and this 45, so both of them are equal to each other. Well guys, thank you for tuning in.